Thank you. Good evening, everybody. My name is Okeke Emmanuel from the Department of Biochemistry, University of Nigeria. My presentation today will be on the quality assessment of retail samples of honey using amylase activity and hydroxymethylfurfural content as criteria. The introduction, we all know that honey is a natural sweet substance produced by the worker honeybee from the nectar of plants, from secretion of living parts of plants or excretion of plant sucking insects such as aphids, leafhoppers, scale insects on the living parts of the plants, which these bees collect, transform by combining with specific substances of their own, deposit, dehydrate, store, and leave in the honeycomb to ripen and mature. Honey production is a common business and is perceived to have a high economic value in the study area. The study area here is Nsukka, a town in southeastern Nigeria.
Professor, sorry, can you make it full screen so that everyone can see it properly?
Okay.
So the play button.
Wait, let me see where to do that.
So the next one, play button.
This one?
No, the red one, I think. Yeah.
Is it okay now?
Yes, perfect.
Okay. So like I said, honey production is a common business in Nsukka, a town in southeastern Nigeria. They're well known for production of honey in large quantity. So however, in recent years, limited production of honey caused a rise in honey prices, in turn, an increase in honey adulteration by producers through the addition of different commercial sugar syrups. Honey has become the target of adulteration with cheaper sweetener in many countries, including some places in Africa and Nigeria in particular. Honey is subjected to adulteration with inexpensive sweeteners such as refined cane sugar, beet sugar, high fructose corn syrup, maltose syrup, resulting in a high commercial profit and a reduced diastase number. The diastase number now is in form of amylase activity. Importance of honey. Honey is used for nutritional, medicinal, industrial purposes, and it is an important commodity in international markets. Honey production has the potential to become a major foreign exchange earner for Nigeria if qualities of the products are able to meet the international standard. These are some other importance of honey. Honey is used as food, is used in cosmetics, is used in medicine and folklore, especially in wound healing. It's used in other pharmaceuticals, in beverages, both alcoholic and non-alcoholic, and also as a sweetener in food and beverage industries. The quality criteria used in assessment of honey quality, some of the physical-chemical properties are the specific gravity, the pH, the electrical conductivity, the moisture content, the HMF content, which is 5-hydroxymethylfurfural aldehyde content, which I'll be using as HMF. HMF here is an indigenous foreign substance formed during acid catalysis. Acid catalyzed dehydration of hexoses, mainly fructose. HMF measurement is used to evaluate honey quality. HMF is generally not present in honey, but its content increases during conditioning and storage. It can thus reduce the nutritional value of honey through the dehydration of liable components. At high concentration, it can influence the color of honey, the opinion concerning the times of and health risk and potential cytotoxic, genotoxic, carcinogenic effect of HMF is not consistent. It's not consistent whether this causes gene toxicity or whether it's carcinogenic. HMF is also a good indicator of adulteration of honey by the addition of invert sugar. According to Zabrowska and Volova 2014, Many countries have set a national limit for HMF content in honey to 40 milligram per kg, but the current international regulatory standard allows up to 80 milligram per kg for honey for tropical origin. Another criteria is amylase activity. Amylases are glycoside hydroxylases acting on alpha-1,4-glycosidic bond of complex polysaccharides such as starch, reducing into short polysaccharide fragments or oligosaccharides. The amylase component of honey has received considerable attention over the years due to its use of freshness indicator. The enzyme originates from the salivary secretion of bees. The aim of this research was to assess the quality and freshness of retail honey samples obtained from the local market retailers in comparison to set international standard. And this aim was achieved through determination of selected quality parameters such as reducing sugar, ash content, moisture content, lipids, specific gravity, total solids, refractive index, pH, free acidity, and some other minerals such as iron, zinc, selenium, and manganese. In addition, we also use the determination of amylase activity and determination of hydroxymethyl furfural content, among others. So this is our sample. We collected 20 local honey samples and 1 branded sample from a market in Osaka, Okeke market, and subjected them all to the testing. These are some standard methods used in analyzing the samples, which are documented by AOC. And the statistical analysis was done using SPSS ANOVA to check the level of statistical significance. And then my results. From this table, we can see the amylase activity and HMF number of the 20 honey samples. The last one is the standard, which is the one already branded. So from the table below, the HM content of the honey samples can be seen that sample 9 had the lowest HMF content of 0.78, while sample 4 had the highest content of 104.3. But the cutoff for this quality criteria is placed at 40 milligram and 80 milligram per kg for honey of tropical region. The HM content of these honey samples differs significantly as P less than 0.05. Then for the amylase activity, which is expressed at their diastase number, ranges from 2.88 diastase number for sample 17 to 10.96 diastase number for sample 18. The cutoff for this quality criteria is packed at greater or less than 3 diastase number. And also, we also notice that amylase activity of the honey sample differs significantly at P less than 0.05. This is also the continuation of the table for these 20 samples, including the branded sample. The table 2 shows the reducing sugar and then the ash content. The reducing sugar content ranges from 42% to 84.12%, with a mean value of 59.94%. The reducing sugar content of the honey sample differs significantly. It differs significantly at P less than 0.05. And then the ash content ranges from 0.20% to 0.86%, with a mean value of 0.49%. And it was also found to be significant at P, to differ significantly at P less than 0.05. Table 3 shows the moisture content, and the moisture content we have to talk about the total solid and the refractive index. So the moisture content and total solid of honey samples, like okay, it varies from 9.08 to 16.96 for sample 3 and sample 19 respectively, with a mean value of 12.89%. And we found that the total solids were between 83.24% to 90.92%, with mean value of 87.11%. The moisture content and total solids of the honey samples differ significantly at P less than 0.05. A very strong and significant positive correlation was established between total solid and moisture content of the honey samples at P less than 0.05. The acidity, which is now expressed at in mean pH value and the mean free acidity. The pH value ranges from 3.57 for sample 5 to 4.77 for sample 13, 4.77 for sample 13, with a mean pH value of 21.32 mE per kg. It was also noticed that the pH value and free acidity of the honey samples differ significantly, just like the other parameters. This is the specific activity. The specific activity, when compared with the, ranges from 1.41 gram per centimeter cube to 1.45 gram per centimeter cube, with a mean value of 1.43 gram per centimeter cube. The specific gravity of the honey, like other criteria, differs significantly at P less than 0.05. The lipid content. The fat content ranges from 0.08 to 0.14, and it was found to differ significantly. There was a significant difference when compared with the standard. For the minerals, we checked the iron, the manganese, the zinc, and the selenium. And from the values, we can see that the iron content ranges from 2.47 microgram per gram to 99.07 microgram per gram, with a mean value of 21.04 microgram per gram. And then for manganese, the content ranges from 1.41 microgram per gram to 8.38 microgram per gram, with a mean value of 30.01 microgram per gram. In furtherance, we headed to zinc to check the zinc content, which ranged from 1.09 microgram per gram to 15.49 microgram per gram, with a mean value of 4.08 microgram per gram. And also we found out that the mineral content of the samples differed significantly when compared with the control, which is the standard brand honey we also got from the market. Now, checking this from the values we got from the samples and the criteria we used, we found out that this honey met the international standard, even though there are some variations. But this variation, we said, could be as a result of storage. The manner of handling must have affected the quality of these honey samples. So these figures can further be improved by employing proper production, extraction, storage techniques. The study has shown high export potential for honey from the study area, Okeke, southeastern Nigeria, since some of the samples were within the acceptable standard for moisture, which is said to be the most important criteria for international trade. That's the moisture content of honey. So based on the parameters These samples gradually conform to international standard and can therefore be said to be of good quality. But there are some limitations to our work. We found out that the figures can further be improved by employing proper production, as I said before, the extraction and the storage techniques, being that this study area is actually a rural village, and we lack some of this extraction procedure, which in sometimes is manual, and storage is by mere traditional means of storage. So there is need for further subject retail honey samples to test that could more specifically pinpoint adulterants. Examples of such tests are elemental analysis, isotopic radio mass spectrometry, which detect adulteration with syrup from C4 plants, and attenuated total reflectance Fourier transfer infrared spectrometry for detection of adulteration with standard sugar solutions and syrup. I want to use this opportunity to thank Professor Bennett Chima Wanguma, who provided this work, and Chidima Naha, who contributed immensely in the laboratory work to make sure that this research was achieved, and also to the organizers of this conference for giving me the opportunity to share this idea with the scientific community. Thank you.